Alright, here's example 2 with intersections of intervals. So again, we're still talking about intersections, so A intersect B equals the set of all x such that x is an element of A and x is an element of B. Okay, so x has to appear in both A and B to be part of the intersection, because remember the intersection is the overlap, the common elements, the elements they share, things like that. So example 2, A is the interval from 1 to 4 like this, B is the interval from 4 to 7 like this, and we want to know what is A intersect B. Okay. So remember, we talked about this in the previous video. When you intersect two intervals, there are only 3 possible types of answers. And one possible type of answer is an interval, or you can get a single point, or you can get the empty set. Okay. So we saw an example of this in the previous video with an interval, so now we'll see something like this with a single point. So spoiler alert, that's what the answer is going to be. Anyway, so we're just going to approach it the exact same way we did in example 1. So let's draw this on a number line. Okay, so again what we do is we draw both of them on a number line, one above the other like this, and keep the scales, or keep the keep the systems the same. So we'll put this one as 1 to 4, so we'll label it like, so we'll put 1 over here, so here's 1, we'll put 4 over here. So this one's 4 to 7, so we want to keep the numbers lined up, is what I was trying to say. Keep the numbers lined up, so 4 lines up with 4, 7 has to come over this way, so 1, 4, 7, okay? Okay, now how do the circles go? Are they open, closed, filled in, not filled in, things like that? So let's 1 to 4 like this. Remember, we talked a lot about converting this to inequality notation, so that's 1 strictly less than x because of the rounded parenthesis, less than or equal to 4 because of the square bracket, okay? So that's going to correspond to open circle on the 1, closed circle on the 4, okay, and then everything in between. Okay, now what about this one here? So we have square bracket on the 4, so that means 4 is less than or equal to x, and then strictly less than 7. Okay, so we have that going on. Now remember, less than or equal to corresponds to a closed circle, and then strictly less than corresponds to an open circle. Okay, so we have that going on. Okay, so now that we have that, what we can do is zoom in a little bit. Okay, we'll zoom in a little bit here, and then we will make a number line down here, and then we literally look for the overlap. Okay, because remember, an intersection is overlap, because it's all the things that are in A and B, so it's where the literally where the overlap is. And since we can actually just draw these out on a number line, we can literally just look for the overlap. Okay, so where is the overlap? Well, 1 to 4, all this stuff is only on the first interval. All this stuff is only on the second interval. The only thing they have in common is just this one number here, this 1, 4. Okay, so that's maybe use a different color. That's the only thing they have in common, is just that 4. So just this 4 right here, that's it. Okay, that's all they have in common. So if I drop that down, I've got that 4 right there. But that's it. Everything to the right of 4, there's nothing on the first interval. Okay, if we go to the left of 4, there's nothing on the second interval. Okay, so only 4 itself is part of the intersection. So as we see here, the intersection is only a single point because these guys only overlap in one point, right? 1 is less than, excuse me, 1 is less than x is less than or equal to 4. Okay, so 1 is strictly less than x is less than or equal to 4, and then 4 is less than or equal to x is strictly less than 7. Okay, so x could be 4 in this interval, and x could be 4 in this interval. Okay, so they overlap at 4, but in this first interval, x is never larger than 4, right? X stops at 4, it's never larger than 4. In this second interval, x is never smaller than 4. Okay, so the only overlap is just that point 4. Okay, so there's a couple ways of thinking about it, but if you see on a number line here, it's easier to see on a number line, I think, anyway. So this first interval never goes to the right of 4. The second one never goes to the left of 4. Okay, so they only overlap right at 4. And again, you got to be careful. It's because they both have the closed bracket here. Okay, they both have the closed bracket. So they do overlap in that single point because the point 4 is part of both of these intervals. Okay. So how do we express the answer then? Well, if they only overlap in a single point, then remember an intersection is still a set. So then what we say is just A intersect B equals 4. So this is wrong. Saying it like this is wrong. So your answer has to be a set. So be very, very careful about that. You have to enclose it in curly braces like that, okay? And that's our answer here. Okay, so again, when you intersect two intervals, there are only 3 possible types of answers. Your first possible type is an interval, that's what we saw in example 1 in the previous video. Second possible type is a single point, which is what we had just here, just now. And then the third type is the empty set, which you may guess is what's coming up in example 3. So anyway, again, we just did exactly the same thing we did in example 1. Draw each on a number line, line up the numbers, and then look for the overlap. In this case, it just turned out the overlap was only one single point. And again, since an intersection is a set, you have to answer with the curly braces if you only have one point. Okay. So we can't answer this with like square brackets, so don't say this. That's kind of weird. It's people might know what you mean, but it really is incorrect because it's not an interval. That's only for interval notation. Okay, so don't do that. That's just, it's weird. It's technically incorrect, so you don't want to do that. So remember, it's just a set consisting of only one element, and it's just the number 4. Okay, so do the curly brace thing there. Okay, so that's example 2 with intersections of intervals.